Oh, I'm not live.
You're sabotaging the score.
Yeah, they don't have.
I was supposed to hit a live button. Let me back up just a sec. Well, I'll just do a quick. Yeah, that's their fault for not being here. All right, so that's now being recorded, and I don't know, get a driver's license. Okay, so you're all juniors. Okay, so guys at home, I apologize. I forgot to hit go live on YouTube. I thought I just had to do it on the software I'm using. So welcome. Now we have 4 concurrent viewers. Good. All right. People at home, if you can let me know if you can hear me in the chat, that would be awesome. Just type in the chat. It's just like people I don't know. Yeah, okay. Well, it is public. This stream. Yeah. Okay. So again, for the people at home, reaction rates, we have a change in concentration per time. This is just background info you guys can go through and understand that what the units are for this. It's molarity times seconds, or molarity moles per liter times seconds, I should say. And the actual rates are averages. When we get to instantaneous rates, that's where we need some data or a graph that allows us to get the slope of a line tangent to the curves on these things. So when you guys are looking at this equation for this one, we have 2NO2 going to 2NO plus O2. And so the curve for this one is the same as the curve for the NO. So NO2 and NO have the same curve. They also have the same coefficients, okay? O2 is half of the rise of the NO, and notice its coefficient is 1, which is half of that, okay? So for instantaneous rates, you can go purely from that data to get the rate. You don't have to do much in the way of calculating rates on the test. It's just really background information that you need to have to help you with the other stuff, okay? Again, differential rate law, the most important thing is this. You should know that. It's got to be determined experimentally. And again, it depends only on the concentration, and it's often just called the rate law instead of the differentiated or differential. Yeah. Well, on a test, you have to be given the data. You guys in your lab got your own data. You were using that to get your stuff. For this one, like for a test or for quizzes or the AP test, they give you the tables like we looked at, and you're going to see it when we do the examples here. Yeah, it's always given to you. It has to be, yeah, to solve those. Or a graph to get the rate law. You can use graphs. We'll show you everything you need to know for the test. Okay. They make you do a lab while you're, yeah, thankfully no. That would suck. Well, they give you a lab question, but yeah. And then after differential rate law, we covered integrated rate law. Okay, listen on this. You get the equations for integrated on the test. You're mostly looking at first and second order for that stuff on our test. Okay, just heads up. And half-life, you only have to deal with first order, which is shown up there. And that's all given to you. You will also have to be able to determine the order by graphs. So this graph would represent which order, the first graph on the left. Concentration versus time is a straight line descending. You already missed it. 0, yeah. Natural log, this is first, and 1 over is second. So make sure you know that. And no, remember second is the only one that's ascending. Its k is positive. So second order has a positive k. these two have a negative k value, negative slope. Okay, remember k is the slope. Okay. And you can see it in the equations too that are given to you. You've got a negative k for first order and 0 order, second order it's positive. And on the equation sheet, they give you all three of them. I'm just telling you tomorrow you're not likely to see 0 order for integrated rate law calculations. Okay. For those of you that showed up, I'll drop that here. It doesn't matter. I mean, you get the equation sheet. I forget. You show up and there's one on there. I'll be printing the test in the morning if you want to try to break into the copy room while I'm there. And trust me, I'll never let him see a test. Ever. Yeah. Or I already printed them and put them in my filing cabinet and locked it. You're fine. Yeah, I'll be here. Ooh, Chex Mix. Is it the regular one? It's the best one. Yeah. I like the bold one too. Nice. What happened to your thumb? It was like kind of like they don't extend all the way. Is it broken?
I honestly don't.
So the way we're going tonight is I'm giving you all the background info first, then we're gonna run practice until you're tired of it. Yeah. Until 7:30 when I'm absolutely going to get something to eat before I die. Right. Which could be in as little as 15 minutes if, yeah. What's up? We're all quiet now that it's not you, it's us. I didn't know Isaac was going to be here. Yeah. It's awkward. All right. All right. Are you guys good on what, like, the zero means on these equations? All right, we're going to do some practice, so we'll see if you know it or not. Yeah, okay. All right, so another thing that we got into were reaction mechanisms. And again, I'm going to give you guys practice to back up each of these. But molecularity, just remember as a definition, is telling us how many molecules are basically reacting in a step or a series of steps. So if it's unimolecular, you'll have something, let me give you some examples here. And again, people at home, you're probably not going to be able to see this because I'm using a drawing app. But if we have something like AB going to A2, that doesn't actually work either. That would be bimolecular if I balance it. If we have AB decomposing into A plus B, that would be unimolecular. If we had like 2AB going to that, that would be bimolecular because you have two ABs that have to hit each other. And then termolecular is how many molecules? 3, which is nearly impossible in a single step reaction. Okay. So that could be something like, I don't even know, something like that. But trying to get 3 molecules to hit, again, at the same time with the correct orientation and energy to break bonds is nearly impossible. Oh, you just have to be able to know all of them. But yeah, I mean, as far as that, but it's, again, this is background stuff. So the other thing you need to remember is which step is the rate determining step. The slow, yeah, so slow step is the rate determining step. That's really gonna, I mean, everything has to be as, like, that's gonna limit everything because it's the slowest. Okay. It's like me. I'm the slowest person out of the three siblings that I'm part of, and so I always slowed them down. Yeah. I'm kidding. I'm the smartest of them. Because I'm left-handed. All right, so. Not, that's a lie. And so, proof. Wait, I have the burden of proof. They had higher GPAs than I did. One was a valedictorian, but right, yeah, that was my argument. Was that doesn't mean you're smarter. That means you work harder. Yeah. Like now, in my position in life, it means nothing. Yeah. So for you guys, yeah, it matters a little bit. All right, so we're starting kind of at the end and going through reaction mechanisms first, since they were the last thing we did. So, and again, I've taken and gone with the highlights that you need to know for the test. So, they're not. I mean, no, it's not. Don't put words in my mouth. Okay. So on this one, we've got a slow first step and a fast second step, and it wants the overall equation. How do we get that? Great. Yeah, so you got to add them together. Then write the rate law. Remember, the slow step is the rate determining step. And then identifying the intermediates. Okay. Ivan, you moved to Arkansas? That's crazy. I thought you came back. Oh, sorry, I was talking to Ivan on the chat here on YouTube. No, he's in Arkansas. Arkansas. Oh, sorry. Okay. This is really not going to work for the people at home if they can't see what I'm writing on here. I don't know. I think the only person watching is the former student, Ivan. Well, they can ask you for help. So, I could set up a camera and just do it on a whiteboard, but whoa.
Watch it.
All right, we're back up. Okay. All we need is the internet to go down, and that would make everything just right. So, obviously, you'd still have to take the test tomorrow, but yeah. Yes. And yes. And yes.
Slave.
Yeah, slay it. Okay. Mark that one off as a slay for that kid that I can't name, Elisa. And Ivan, it's AP Chem. That's why I have to be here at 6:20 at night. Yeah. It's past my bedtime in Arkansas right now. It's 8:20. Okay. Hey, I'm gonna do this question backwards because it's like Mater. So those are the intermediates. Okay. C is the intermediate. If I add those to get now I'm not going backwards. Now I'm gonna skip to the beginning and do. I know this is crazy. And I'm gonna add these up, and I get A plus 2B yields D plus E. Okay. Sure. And then the rate law's got to match up with the slow step, which is that. So rate equals K, A to the first power, B to the what power second, and that's the rate law. If you got that right, what are you excited for? That was an easy one. Okay, so yeah, no, I'm kidding. Good job. Well, these are just practice examples. I don't like when you guys pin me down on things. No, I won't know. Yeah, because I look at it after the fact. Yeah, but that's a valid question. It is. Nice. Follow-up question written by Peyton. Is the overall order 3? The answer to that is yes. Okay. See you, Ivan. I'm not doing study sessions ever again. Okay. So none of the other AP teachers do them. They think I'm stupid and crazy. Okay. Now let's step it up a notch. Let's kick it up a notch, guys, if you will. Tom, can you walk over to Taco Express and I can do the study session at home with you? Okay. Are they not open after this? What time do they close?
Check online.
Are we gonna have to go to Carl's Jr.? Jack and a Crack? Okay.
The milkshakes.
Oh, at Jack in the Box? Never had one. Yeah. Are they good, Tom? No, at Jack in the Box, the milkshakes. Cynthia, you're gonna take Lefty. Sorry.
He has a lot, so not like I'm sorry. That's fair. Okay.
Whoa! You went. Look what you did. You offended her. She's left-handed. All right. How dare you? All right.
That's why I don't get it.
The people at home are missing a pretty serious milkshake debate right now. Yeah. I think I'm lactose intolerant, so.
Oh wait a minute. Okay. Let me do it and then.
Shoot, I gotta do it. Hang on. I forgot this one has an equilibrium in it. Nothing? Oh, yeah, I got it. All right, I got it. You're on Classroom. What's that? No, you just have to be willing. Yeah. You just have to have a chem credential, which I do. And a College Board account that they give you when you stupidly sign up to teach it. Yeah. And then you have an AP bio teacher that retires. They don't have a teacher to replace her, and they make you AP Chem teacher 12 years ago. Yeah. I was like, okay, I'll do it. And then after the first year, I was like, I don't think I can do this anymore. And yeah. But then the next year we did better. Third year we did better, Then last year we kind of dipped. And then this year we're going to go dip more. Hey, prove me wrong. All right, yeah. Guys, succeed just to spite me. That's the best way to do it. Okay, so just to prove me wrong. All right. How many got that far? Good. Okay. Is that bad? Oh, you got it. Okay. I didn't know if that was a cry of pain, like you didn't get it, or Tom, did you get it? Right? How? All right. Okay. When you have a fast equilibrium, remember you can replace that, which is the intermediate, with that. Okay. I'm going to be honest. I didn't put one of these on the test. No, I won't lie to you about the test. I may forget things or not remember what I wrote, but or spell instantaneous correctly. Instantaneous. It's like a disease. Okay. For kinetics, The model, see Jackie, the kinetics model is known as the... You talk a lot more at the study session than you do in class. It's weird. Yeah. Melissa, that is correct. Sorry, Melissa's on here. Yeah, it's Melissa. I'm sorry, you can't see the writing because the pen app's not showing up on YouTube.
Yeah, it just shows the pen scrolling.
It does.
Like you see the cursor moving your pen,
but you can't see the writing. Son of a. Yeah, I blew it. Sorry. Okay. All right. For the kinetics model, the collision model is what we have. You should know what an activated complex, also known as an intermediate or transition state, is. Okay. Remember, on an energy diagram, that is the top of the energy diagram hill. The top of E sub A is the intermediate. So for those of you that are here on an exothermic diagram, that would be right there. Okay. At that point, that's the go or no go for a reaction. If it doesn't get enough energy to pass that point, it won't go, it won't start. Okay. Remember that they, as far as to get them to react, they've got to be oriented in the correct way, like pointed at each other, and they have to have enough energy to break bonds. Whoops. I'm gonna real quickly. Wait, you guys can see what's in the washes. Okay. Questions? There are questions. Okay. All right. I better shut that before. I better make sure you don't know my pass. Oh, I have one too. No, I have my own. Yeah, I bought it from, I know, I never ate mine. It's from Eric. You're not going to eat it because it's from last week? It's... Looks like bacon. Okay, catalyst. Enzymes are biological catalysts. Future doctors. Oh, oh my gosh. Hello. That's your sister. This is worse than when Isaac came in the room. Okay. It's just as long. How are you doing?
I'm good. How are you
Good,
doing?
good.
I just got off of work.
All right. Where are you working?
I work at Brenda. I'm in charge of the after school program.
Oh, I was like hoping it was like food related so I could get free food, but all right, that's cool. Well, good for you. Yeah. All right. Good seeing you. Don't tell her, but your sister's the best. Is she still there? Oh, shoot. Okay. All right. Okay. Only she could convince me to take a field trip with a book club at Madera High to John's Incredible. They needed drivers. Yeah, Miss Crusoe used to operate it. Ask her about it. Yeah, I drove him to John's Incredible, and yeah, it was the nerdiest thing I've ever. I mean, I don't know how we nerded up John's Incredible that badly, but we did. Yeah, but I had fun. Yeah, you guys were little, I think, when. All right. Okay, on catalyst. Homogeneous for catalyst means the catalyst is the same phase as the reactants. Heterogeneous means it's a different phase than the reactants, okay? But remember that catalysts are not used up in a reaction. They are there at the beginning and the end. We'll look at an equation again for that, but they're kind of the opposite of the intermediate when you're adding equations together. The catalyst will always show up at the beginning and the end, okay? Which also cancels them out in the overall reaction. Remember adsorption? For adsorption. I'm done. All right, let's go home. All right. You're driving. You are driving. Okay. Well, he's got his driving test next Monday. So yeah. Did you go to Fresno? Exposed. All right, good. Did you get your phone out while you were driving during the test and film it? Okay. All right. Okay. Just so we can get through the practice here. Adsorption is the collection of a substance on the catalyst surface. So you got to, like the catalyst that we use two kinds. For the hydrogen peroxide demo, we used manganese dioxide for one of them. That's a solid, so that's a heterogeneous catalyst. And on the surface of that solid, it's in the notes again, but the reactants get onto the surface. That's adsorption. They collect on the surface, react, and then take off. Okay. Catalysts change the energy pathway, meaning they drop the activation energy. So if I have a catalyst with an exothermic reaction like this would be the uncatalyzed. If I take and drop the activation energy, we get the catalyzed. So that's going to go faster because the activation energy hump is smaller. Okay. So, and that's another thing to look out for on tests. If they give you like 3 different activation energy curves and ask you which one's going to be the fastest reactor, you want to go with the one that's got the smallest activation energy hill. So it'd be this one, the one in the middle there. Okay. Yeah, which should be the fastest reacting. Yeah, the smaller the E sub A, the energy hill, the faster the reaction. Forgot this was on the slide after I drew mine. So yeah, it's a little easier with Pear Deck because I have another slide. I have a thing open on here where I can see what's coming up now. So you can see on there, you can see uncatalyzed versus catalyzed, and you don't have to do anything with delta H on this test. That's what we're dealing with now on this graph is the delta H portion in thermochem. This one would be? I'm sorry, what'd you say was it? Endothermic. Yeah, good. So if the reactants have less energy than the products, it's endothermic. So yeah, this would be an endothermic, and they show it catalyzed on this one. Yes.
Would that energy be potential energy or kinetic energy?
It's potential energy, yeah. So what they have before versus what they have after is always going to be a measure of potential energy.
Even in the product?
Yeah. It's what they have stored in their bonds after. So before they have potential energy stored in their bonds as reactants, if the products have more energy stored in the bonds afterwards, like after they've done their rearranging into new products, then it's endothermic if they have more energy stored in there. That's why endothermics are kind of, they're a little tougher to be spontaneous at room temperature because you usually see it the other way around where things want to lose energy. They want a negative delta H. With endothermic, they're gaining energy, which is not usually what they want to do. So usually what's happening there is they must be making a bigger mess entropy-wise. So like the one I showed you guys that went from 2 solids mixed together to a liquid goop, that was more entropy at the end, even though it was endothermic. So they offset each other. In fact, the whole course basically at the end is you have entropy versus enthalpy, which is delta H. And whichever one wins out will cause the reaction to go or not go. Okay, so it's really a battle between enthalpy and entropy, mass and heat. Okay. Universe is expanding, which is a bigger mass, which is why entropy is always increasing in the universe. Enthalpy is constant. Okay. On the Maxwell Boltzmann diagram, you may or may not be asked to draw. Why is a kid from regular chem on my YouTube watching this? I know exactly who it is. All right. I didn't give his name. He's just from first period. And it's not Jet. He's in third. Yeah. Okay. Should have made this private. Okay, so I'm just kidding. Nah, he's a good kid. Yeah. So if we have the Maxwell Boltzmann diagram, the effective collisions are the shaded spot. Okay, that you should know, and you should also know what happens if we add a catalyst on the Maxwell Boltzmann diagram. Which way will the E sub A line move if I add a catalyst? Left, yeah. So we'd end up with to the left. Put all your stuff in the box to the left. Okay. So it would do that. Okay. So that makes the effective collisions larger, which means the reaction is going to be faster. Okay. So these are basically two different ways to look at catalyst. One is with the Maxwell Boltzmann diagram, one's with an energy diagram. Or as Dina Leggett says, an energy profile diagram. Dina is smart. Okay. Did she call it mechanism? I can't remember. Yeah, her accent. Yeah. I hate milkshakes. No, I don't. I actually love them. I got nothing. All right. All right, let's look at, hey, this question goes back to 1994. I was in college. You were not born yet. There was another 11 years left before you guys were born. And so on this question, it says this goes back to what we were talking about earlier. The rate law and the K have to be determined from experimental data. Okay. So this is where the pair deck would have come in really handy. I don't know. It's the problem is the streaming part. Okay, we may. All right, do you guys have it open at least?
No.
You might want to open this because you're gonna have to go back and forth between the table and the. Yeah. I don't think I'm going to stream these anymore. It's too confusing. The other one left. Yeah, Jagdeep left like 5 minutes free. I think you're the same person. And that's not racist. I think you're literally the same person. Yeah. Okay. So, for guys, for this one, the first question says, determine the order for each of the reactants, NO and H2 from the data given and show your reasoning. Part 2 says to write the overall rate law and then calculate the K. And then we'll get to C. We'll talk about C together. You're not going to see C on a test, but yeah. Well, just try it and see. Yeah. So, yes. It should be. If not, let me know. It should be in the calendar. Wow. I know. I spent a lot of time on that.
There's just so much stuff that it lags out. I can't spell them. I mean, I haven't looked more. No, like it's not like it's clear, but.
I'll let you guys just figure out what's going on from day to day. Okay. Who's a goof? That's what East Coast people say when they're joking.
What part of the unit is
5.2.
Is this a question of like?
Well, this is the setup, and then if do you have this open? Yeah, then go to the next slide, and those are your questions.
Because I'm taking the 5.1.
Yes.
Yeah, it's the same kind of stuff, yeah.
I need to pay attention, right?
Yes, or the whole thing. Yeah, oh shoot, hang on. Whoa, don't look ahead. All right. All right, so guys, first get the order for each reactant. Do you want to try this first before? Okay. Then get the rate. Focus on the orders for each reactant and the rate law, and then we'll go over that first. Somebody tried to spam the chat on this thing. Melissa, let me get back to you on that one. Melissa, if you open the slideshow, you can check your work because it's a couple slides after this. It's 1.2 divided by 3. Oh, yeah, Melissa, you're correct on the answer you put. I know. Oh, the guy. I'll make it simple. Yeah, he does. I wish Dina had done those. I wish Dina had done all the videos. Okay, what I'm gonna do. You want me to wait, or you guys still? Okay. Nobody's gonna sign up for AP Chem next year. Yeah. I have some honors kids and seniors for next year that want to take it because they couldn't take it this year. I can have Moises teach the class probably. Yeah. I'll just sit in the back and let him teach it. I'll give him all the material over the summer, and then he can be my student teacher. All right. Oh, I know he would. I think I'm going to post it early and just put every set of notes up there. Oh, I thought you guys had it up already. Okay. All right. What the bleep is a sub box? Oh. I think Zoom would have been easier to do this with. I don't know. I think for the next test, I'm just going to tell them they got to be here if they want to be at the study session. Yeah. Or I'm just not going to do these anymore. Yeah. Okay. All right. I mean, no. Is it okay if I go over this one? Okay. The first part? Okay. So let's get the orders of each one. So first of all, I'm going to look for H2 first just because I want to. Okay. So I'm focusing on that. When you guys are trying to find the rate for one reactant, you've got to hold the other one constant. So experiments 1 and 2 hold NO constant. That means they're going to cancel each other out. If I take this and divide it by the point 0.002 and divide it by the 0.001, what do I get? 2. So let me show you, it might be easier on the board. Let me show you this. Okay. So hang on guys. Just so she can catch on to this. Oh, thank you. So rate equals K. We have H2. We have NO. We do not know the value for the orders, the exponents. Okay. So in that case, to find H2, I've got to hold those constant. And yeah, so what I do then is I'll take this divided by that. That's going to be a factor of 2. And if I take that rate and divide it by that rate, what is that a factor of? 2. So this is rate equals, yeah, the N is going to equal 1 in this case, which means H2 is, yeah, first order. Okay. I mean, you could technically set up the equations and divide them and all that stuff, but if you can just picture like, okay, that's a factor of 2, that's a factor of 2, then you can pretty much set it up. This is the rate, this is the concentration, rate equals K H2NO. We just figured out that H2 is a rate of, or I'm sorry, a order of 1. Okay. No, because I could write that just on the left just as easily as that, so it doesn't matter. Yeah. Once I get H2, then I go after the NO. So I've got to find 2 equations that hold H2 constant, 3 and 4. Okay. Yeah. So to find the NO, I'll hold those guys constant. And if I divide this, by the 0.002 by the 0.001, I get a factor of 2 there. But this one, if I divide those two, what do I get? 4. So rate is 4, a factor of 4. The concentration is a factor of 2. That means M is going to equal 2, which is second order. So NO is second order. Now, let me ask a follow-up question. If I double the hydrogen concentration, what'll happen to the rate? It'll double. If I double the concentration of NO, what'll it do? Quadruple. Second order means it's getting squared. Okay. First order means it's the 1-to-1 proportion. Okay. So, and if it's 0 order, changing the concentration does what to the reaction rate? No effect. 0 order means no effect, because if that hydrogen ended up being 0 order, that would mean that it's effectively what amount? What's anything to the 0 power? 1, which means it's not going to affect anything. Okay. So that's, yeah, those are, just remember like what the order actually means. Okay. All right. Yeah, if it's first order, whatever you do to the concentration, it'll do it to the rate. If it's second, it'll square it. Yeah. I mean, so the order is basically an exponent of what it'll do to the reaction rate. Yeah, by changing it. Okay, so then let me just skip ahead here and look at the next question. So far we've done part A. Part B says to calculate the value of the rate constant K for the reaction, include units. So just to save a little time, let me show you guys what I did with part A, and this might help Cynthia since she was gone during this. This is like if you were showing the work, which I don't make you do on the test, and they don't usually make you do. If I take experiment 2 and divide it by experiment 1, which I did to find the H2, I get 3.6 divided by 1.8, which is 2, and I get that divided by that, which is 2 to the n power. Okay, once I figure that out, I just have to figure out what n is. Okay, and if I know that, that's the order. So that's what I did on there, and you can go back and look at that if you want. For NO, I did the same thing with experiment 4 and 3 because the H2 was held constant in that one. It wasn't changed. Okay, and that's done on purpose in the experiments. Like they hold something constant so that they only have to study one react. We did the same thing with ours. We flooded the NaOH so we wouldn't have to take that into account. Okay. Efficient. And yeah, smart. Okay. So so this one's going to be second order. Then when they go to have you calculate, well, that's the rate law, by the way. And again, it doesn't matter what order you put them in as far as that. I did it 2 different ways. Okay. So then the calculation of the K comes. What do I already gave it away there, but what do I do to calculate the K? Yeah, well, you wanna take one of the experiments and solve for K with the values from the experiment. Okay. So because you're gonna get the same answer no matter what if the experiment is done right. So if I go and solve for K, I get rate over that times that. In fact, on the board, let me just show you real quick. I know you guys can do algebra, but I think that was the rate. Yeah, that's the rate law. So if I want to get K by itself, I have to divide by these guys. And I'll get so then all I have to do is just plug in some values from one of the experiments to get the K. Okay. The fun part is coming up with the units for it, which we'll show you guys. Yeah. Since this is third order, the units are going to be liters squared over moles squared times minutes. Why is it third order? Yeah. 1 plus 2 is 3. Good. Yeah. Well done, Peyton. Finger gunning what you did. I know. All right. So it's after school. I can, yeah. All right. And I'm not on camera. So sideways. It's Madeira. Hold it sideways. Okay. Madeira, Chowchilla. Okay. All right. So a shotgun, because they're nice people. Yeah. Sorry, I am also a white person. Okay. All right. So notice. Here's what I want you to think about is don't let that throw you. Because I know some people would get 5,000 and go, that can't be right. That's too big. Somehow it doesn't look right. Like instantaneous. But this is not like instantaneous. Okay, this could possibly be the rate constant K. Okay, the higher the K, the more effective the collisions, and the faster the reaction. Okay, so whatever's going on here is a pretty, decent reaction rate. So when you plug in these numbers, the other thing to be careful with, if you have a square on that thing, make sure to square that in the calculator, because I've made that mistake. Just really be careful on that, okay, because that can mess you up. If it's if it's second order for the K, what would the units be? No, third order is liters squared over moles squared times minutes. What would second order be? Just take it down. Okay, so third order gives me liters squared over moles squared times minutes. First order is just minutes to the -1. If it's second order, what would the units be? That would be second order overall for a K value. So let me go through the units for K. If it's first order, it's going to be minutes to the -1. Okay, or whatever value, seconds, hours, whatever it is. If it's second, it's liters per moles. I believe they go over this in one of the videos too. Yeah. And if it's third, it's liters squared over moles squared times minutes. So if you're not good with units in the algebra, memorize that. So if you're good at memorizing things, I would memorize that. If you're good at algebra, then don't worry about wasting your time memorizing that. But either way, don't be overconfident in this. Okay, don't go, I'll figure it out tomorrow when I get the test. Okay, so, yeah. Yeah.
Is that how they cancel out?
When it's all done, that's what they would cancel out as. So when I look at this, I have, like this ends up being moles squared on the bottom, which is, let me clear this mess up real quick. Oh, did you still need that?
No.
Oh, it's on the video too. Watch the video. Yeah. Yeah. If you have a few hours, watch all those videos and you'll do as good as you put effort in. So that's right. Yeah. It's a good start. Okay. Now you just got to watch all those videos again. Okay. So part C. I'm going to go over part C, but let me just double check here. I'm looking. What about anything that reflects? Okay. It's like so close. It's like right here, and you can't get to it. Okay. If anybody tries to jump over here, I will. Yeah. I'll get rid of the multiple choice and give you more free response. Okay. Yeah, this is not on there. Do you want me to just skip it then for now?
Yeah.
Okay. Yeah, it's not on here. Yep. You are always the funny one in your family. Yeah, okay. He has a brother, yeah. But Aryan's funnier, yeah. He's a nice guy, don't get me wrong. All right. I like his dog, but... Well, I've held his dog. His dog bit me. No, I'm just kidding, yeah. He doesn't bite, he just tries to jump on me when I go over there. Yeah. Oh, yeah, you told me that. Yeah. Hashtag Wayne and Billy. Pretty sure Wayne and Billy are, yeah. All right, D. Not that there's anything. Okay, the following sequence of elementary steps is a proposed mechanism for the reaction. Based on the data presented, which of the above is the rate determining step? Show that the mechanism is consistent with the observed rate law for the reaction and the overall stoichiometry of the reaction. Let me explain what this means in layperson's terms. Okay. They basically want to know if this thing works. So if you add up everything, would it add up to the overall, and does the slow work out for this thing is basically what they're asking. So let me take you guys through this part. You're not going to see anything that's tough, but I really made the study session practice tougher than, so when you get to the test, it's like, okay, this isn't bad. Yeah, okay. It's my usual move. Okay. Oops. I didn't. Sorry. Okay. All right. So let's look at this thing. First of all, the rate determining step, or first of all, what is the overall reaction for this thing? Let's go back to that. Hang on, I'm going back. Okay. So we have 2NO plus 2H2 yields N2 plus 2H2O. Okay. So one of the things they're looking for is, do these add up to that overall reaction equation? Okay. So let's combine them together into one equation. Now this one's 3 steps. What's going to cancel out between equations 1 and 2? Yeah, that would be classified as an intermediate. Okay. Anything else between 2 and 3? And 2 is another intermediate that forms. And I think we got everything. So we would end up with 2NO, if we add this up, plus 2H2, and that yields N2 plus 2H2O. Does that match up with the overall? Can you go back and check it for me? Okay, I can go back if you want. It does. Okay, sorry. Let me go back. All right. So used to working with Paradigm. Okay, so we answered part 2. Like when they said the overall stoichiometry for the reaction, they mean, does it add up to the overall? Okay, so the overall stoichiometry is basically 2 of these for every 2 of these, and you get 1 of those and 2 of those. So if I add all 3 of those up, that matches the overall stoichiometry, meaning the ratios. Okay, so that's part 2. That checks out. For part 1, the observed rate law, if I go with the slow step, does it match up with the rate law? What's the rate law for this thing? Yeah, it's NO squared H2, or NO to the second power. Does it match up with the slow step? Yeah, and the reason why it does is because of that. If you have a fast equilibrium, you can replace this, which is there, with that, which is 2NO. Yeah, you've got 2NO and 1H2, which matches up with... Yeah, so this is an AP release question, and everything you do carries into the next step on those types of questions. Yeah, tomorrow is more piecemeal, like there might be a couple of part, like it's not as long as something like this in each of the, yeah. No, we used it to add up it's a fast step, so it's not part of the rate determining step. Like it was used to add up for the overall stoichiometry. Nothing canceled out from that, so we added it all together when it was over. So basically, like adding the 3 steps gave us, like if you add those 3 together, cancel out things that are alike on both sides of the arrow, you get that, which is consistent with that. Yeah. We already calculated the rate law in the previous step. with the table data. Yeah, we found it was first order. Yeah, so everything carries from one step to the, or from one part of a problem into the next in AP questions. So if you got the wrong rate law, if this were a question on the real AP test and you got the wrong rate law, it would jack you up on this part. You'd end up with, it would mess you up. Some of the questions on the AP test, you can mess up something like that, but still get partial credit on following parts of the question if you carry a wrong answer into it. This one, I don't know how they could, well, they could give you half credit if you demonstrated that it wasn't consistent based on the rate law that you calculated. But yeah, it really depends on how they decide to score it that year. They determine that before the teachers ever, or the people that read it ever get there, but like it's probably already been determined. And it's only February, so. Or I don't know how to say February in Spanish. Februar? 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 No. Am I thinking Russian? I get Russian. I think it's Russian. Februar. Yeah. I know a sample of words in each language, including English, and I don't have a first language. It's moron. So true. All right. Are we almost, how much more do we have? Oh, we only have 2 more slides. Okay. Yeah, I am for reals. Yeah. Taco Express, here we come. All right. Don't follow us. I don't think I can drive students.
But I'm driving.
Oh, Tom's driving? I'm just along for the ride? Okay. No, if I'm in the car, it's cool.
We'll put Aryan in the back.
Should we close the thing over him on the back? Would he fit in my the back thing?
Oh, no, in the bed of the truck.
I have a little thing to put groceries in. You probably fit in there if we took the divider out. Yeah. Are they? Jet Wallbarger was talking trash about my truck. He goes, why didn't you get an American truck? I said, they don't last as long, that's why. Yeah. I just said his name on this thing. Okay. Plus, I can't drive a real big truck, or I look like one of those guys that's like compensating for his height. Yeah, so. I'm going to get Tom like an F-350. I'm going to get Tom a half-ton Ford with a flatbed on the back, and he has to use a ladder to get into it. Or a 1999 Dodge Dakota that's covered in rust and old paint that's chipping off. Yeah. All right. There's no shame in that. Did you get your license already? Permit? Oh yeah, you had the guy that passed away, right? Oh, I thought you had him though, and then yeah. Yeah. Left you for dead. The country. All right. I got some Russian. I got a Russian person leaving spam in the chat. It says Alya Anasova, but it's in Cyrillic. It's in the Russian language. Yeah. Ukraine. All right. Are we doing this or what? Oh, okay. Yeah. We were gonna get out of here on time, but yeah. It's 7:30. Just cut it off and then get out. I'm starving. I know. And you exercised before all of this, so. Good job, Cynthia. Student of the month. Yeah. Student of the month. Here's the rate law from the problem we did as a. I wouldn't say we hate you.
Oh my gosh. My freshman year math teacher made me take 25 notes and a notebook.
Who?
VMR.
She's still here? Oh.
It was like her first year when
I don't know people outside of this building. Okay.
Yeah, everyone else was like.
I may need to bring up a whiteboard for this one. Are we, do you want me to just go over this? Okay. Did you try it? You're not doing anything. Try it!
Wait. Oh, wait. Huh? Is it the thing with like
Yeah, with the thing.
the multiple ones?
Well, no, I didn't even ask about multiple ones on the test. Yeah. I had to cut it. I mean, I can only ask so much on there. Otherwise, we'd be testing for 2 days. It'd be like the NWEA. I don't like when the English and math teachers say we should do it in science instead of in their class, the NWEA. I'm like, there's no science on the NWEA, so stop bothering us with it. Yeah.
One of my questions on the math was about percent error. And I knew how to do it. I looked at it, I was like,
All right. Did you learn that from a math teacher? No. Exactly. Okay, so I don't even care about the cam. I just want you learning common sense stuff like that. Okay. How to use Excel. All right. Oh, percent errors up here. I just had it up there for honors cam because they're doing a lab report. Their first lab report of the year.
it's our first what?
Well, I let them. We do handouts the first semester, and I slowly work them into lab reports, and then by the time they get here, they should. I didn't get that opportunity with you guys. Really.
Yeah, I just got through and
All right. So for the energy diagram, first of all, is this reaction endo or exothermic? Exo. How do you know? Yeah, delta H is negative. So it should look something like that. Okay. Now I will tell you this on the test. This is in the multiple choice section. But I ask a couple of questions about it that will add up to what we're doing here. Yeah. Okay. So, energy can be labeled as H. This is the reactants. This is the products, relatively speaking. The other axis should be reaction progress or time going by, whatever. Okay. But again, you're not going to draw one on the test. You just have to answer questions about it. Okay. The location of the activated complex, which is also known as the intermediate, or would be at the top of the activation energy curve. And then the change when a catalyst is added would be just showing that, the activation energy is dropping. Okay. On that. So that's really pretty much the whole graph. The delta H would be the difference between this and this, which is shown there. Okay. If they ask you for the value of the activation energy, this would be labeled with numbers so that you could calculate. We did this in class in the notes, but you should be able to calculate the activation energy or, from the graph, or the delta H from the graph. Okay. Yeah. No. Yeah. Reaction progress. RXN is short for reaction. Yeah. So it's really just a matter of being able to determine the delta H from a graph, the E sub A, whether it's exo or endo, that kind of stuff. I'll tell you exactly what you should know. Delta H, E sub A, the effect of a catalyst, and whether it's endo or exo. There's 4 questions associated with a graph. on the test. Okay. Out of 10, 4 of them are on that.
Let's go.
Yeah. Okay. Yeah. Okay. You get the half-life equation for first order on the test. The rate constant for a first order reaction is K equals 0.0173 seconds to the -1. Calculate the half-life. Part B is an integrated rate law problem using first order integrated. Okay. Yeah, if you need the equation sheet, there's some in there. Or it's on Classroom. You want to go to Chipotle, Tom? You want to go to Chipotle instead? You have a mom. I've met her. I do? It was chemistry? Well, she should know her chemistry.
Oh my gosh.
But she's in the medical field. I wish she was. If we get Chipotle, I might get sick tonight. We won't have the test tomorrow. Ugh. All right, let's go get Chipotle afterwards. All right. Yeah, I get sick every time I go there, and I'm gonna go again. So yeah. I'll get some Pepto. I have some at home. I have a couple bottles of that. Okay. The equation sheet. Geez, even I have to look at it sometimes. Actually, all the time. Yeah. Wait, was Uday gone during Half-Life? Okay. So, for the half-life equation, remember it's 0.693 over K. You may have to calculate the K and then do the half-life, but in this one they give us the K. So all I have to do is plug it in to the equation, and is it? Do I not trust you, or am I okay? Yeah, 40.06. I'm going to round it to 40.1. And what are the units for this? Seconds. So the half-life of this substance is 40.1 seconds. And again, what that means is if we start with 100% of it, after 40 seconds, we'll be down to 50%. After another 40 seconds, we'll be down to how much? No, it'll never get to 0. So the first 40 seconds, we go to 50%. Second, yeah, 25. And it just keeps approaching 0 without actually ever getting there. Yeah, and so the graph for first order concentration versus time is a curve. That's why when you negative log it, it does that and goes linear. Okay. So negative logging the curve will give you the straight line. Okay. All right. Okay, so for B, this is the equation given to you on the test, on the equation sheet for the test. Remember that they usually give you percentages or concentration, but you can treat them the same, but I would change those percentages to decimals. So it says we started with 100%. That's a decimal of how much? 1. And the natural log of 1 is how much? Just do it in a calculator. 0. So if that's 0, what can I do with it? You get rid of it, cancel it. Yeah, cancel culture. And so cancel the crap out of that thing. Okay. Pretend it's Dave Chappelle. So then the next part is to plug in the 60% as a decimal. Now, this is where you got to be careful because you got to read the question, because this one says, how long would it take to get to 60% left? We only care about what's left, not what we've used. So we can go with the 0.6 on this one. But if it said we used 40%, you'd want to switch it to 60. Yeah. We only care about what's left if you're going to write anything down. Yeah. So that would be the natural log of 0.6, which I need a calculator to do that. Okay. And I'm going to clean up the rest. Oh, shoot. Well, we can get rid of that because it's 0. Okay. Should be. Yeah, it should be. And you already have the k from the previous part, which is going to be, put a negative there because it's in the equation, 0.0173 seconds to the minus 1 times the time, which we don't know. So we're trying to find t in this thing. Okay. So the natural log of 60 divided by negative 0.0173. Yeah. Because it's 60% in decimal. I work it in decimal, otherwise you got to divide by 100. It's a whole. Plus then I got to take into account the 100 for the first the natural log at naught, sub naught. And I don't want to have to do that. So if I use decimals, I get the natural log of 1, which is 0. I get negative 0.511-ish or so. Okay, so then once I get that, I divide it by the 0.0173, but you want to make sure it's negative because the slope is negative. Okay, so in the equation, there's a negative in front of that k, which means the slope's negative. So whatever our k is, we need to make sure to throw a negative in front of it because it's part of the equation. And divide it. This is a negative number divided by a negative number, which is going to give you a positive. And you get about 29.5 seconds. Yeah. Yeah. I divided this into that to get t by itself. Did I screw up?
No.
Let me go to the board. Let me go to the big board. So again, we're getting a 60% left. Okay. This is the correct. I know that's the correct answer, but we'll talk about it on the board here. That means that we've only used up how much of the stuff? 40. So it took us 29.5 seconds to get to 60% remaining. If we went 40.1 seconds, how much would be remaining? Half-life is the amount of time it takes to get to 50%. Okay. We didn't get to 50 yet. We got to 60 left still, so we're short of the half-life. So that answer makes sense. If that should be less than the half-life because we didn't quite get to 50% yet. Okay. It takes a little bit of picturing things in your mind, like how much, what the levels of the concentrations are for these guys before and after. So real quick on this, the natural log of 0.6. If you put that in a calculator, you should get negative. Yeah, I got negative 0.511-ish, just to 3 sig figs for now. Okay. So this is at a certain time, okay? This is in the beginning, okay, initially. That's going to equal 0, so I don't need to put it in there, and then that equals negative kt, and our k is point, yeah, we got the k, that's seconds to the negative 1, and we don't know the time. So all I have to do is divide by that. And my units are going to be seconds because it's seconds negative 1 on the bottom, which will put it on the top when I divide. Okay, so t should equal 29.5 seconds or so. I would really look at 5.3 videos and the notes to look at the practice again if you're not if that one's a little tougher for you. Okay. But that's the integrated rate law question. You'll get at least one of those on the, you'll get one of those on the test. Okay. For you guys, if where you're sitting, if you don't mind putting your chairs up, because I left them down for the study session. I appreciate it.
Here's the college tuition.
Oh, nice. Yeah, keep the. Why don't you recycle them and then you could at least buy probably a textbook by the time you get there if you keep sitting or not.
You know what? I'm already gonna be going to student
Who
debt.
needs to go to college?
I'm already gonna go to student debt. Like,
Go to electrician school. That's what I would do. His brother did that. It was the most genius thing ever.
wait.
Probably like they're doing it is better, or like leaned against the big table maybe, or like put it on one leg and try to balance it. So that's perfect. Yeah.
I did the same thing in the I
I like you guys when you're creative on the chairs. I want to see this one leg balance, the chair balancing.
I don't care.
That's different.
Am I able to drink an energy drink during the test?
Yeah, I don't care.
Okay,
I wouldn't stay up all night if I were you guys.
Too bad.
All right, too late. Okay. I'll be in bed by 9:30 if it helps.
Dang, that's early.